So to find an equation of the line, I need a point and I need a slope. But in 3D, we're going to call that a direction vector.
Does that say negative one?
Yeah, negative one.
There. So I need a point. It does not matter which point you pick, just like when we were working in 2D in our algebra classes. So just for convenience, I'm going to pick the first one. And then the slope, or the direction vector, I can get by doing my final minus initial. So 5 minus negative 2 is 7. Negative 1 minus 3 is negative 4. And 5 minus 4 is 1. So again, we have a point, and we have a direction vector that's going to point where we want this line to go. So kind of interesting for lines in 3D, any direction vector that points in the same direction will generate the same line. So your equations might look different, but it will be the same line. That's actually why question 4 is determine if these are the same line or not. So you know what, you might ask the question, well, what does it matter which one you call the final? You'll get a different direction vector. But it's okay because those two vectors are parallel to one another. They're scalar lines. All right, so the equation of our line is going to be the point plus t times 7, negative 4, 1. So just to remind us from last time, we said the equation of our line is going to be the point as a vector plus t, which is our parameter, times the slope of the direction vector. Questions so far? So if I wanted to clean this up, I can distribute the t. And lastly, I can add these two vectors together. These two are both our vector component forms. This form is nice because you can easily identify a point and the slope, the direction vector. And this one gives you an x of t, a y of t, and a z of t. So if we wanted to write this in our parametric form, we can just say that x of t is whatever the x component is. The y component and the z. And I briefly mentioned last time that you guys are going to do so many of these practice problems that you'll be able to just recognize, once you have a point and direction vector, you can instantly just generate the equations. You'll be able to just write, okay, well, x of t is negative 2 plus 17. Y of t is 3 minus 14. And z of t is 4 plus t. So you don't have to necessarily show all those steps. So we had vector component form, parametric form, And the last one was that symmetric form. So go ahead and grab your equations. Maybe ditch that function notation, just write x equals, just write y equals, just write z equals. And for each of those equations, solve for t. Supposed to be. Once you've done that, since this is all t equals something, now you can just say t equals the x equals the y equals the z. So we want to be able to look at the three different forms and be comfortable. If I gave you an equation of a line in this form, could you pull out the direction vector? You could go, okay, well that's just 7, -4, 1. That's my direction vector. Same idea for parametric forms, just kind of the coefficients, 7, -4, 1. And for our symmetric form, whatever we're being divided by here is our direction vector. So you might look at this and go, oh, this is kind of ugly, but still I can pull the direction vector pretty easily. And then the points are just going to be the changed signs of each of these. So it'll be -2, +3, +1. -2, +3, -4. So -2, +3, +4. Questions? The next question, number 4, says, determine whether the two lines are parallel or identical. So let's just kind of think about some geometry of lines in space for a second. So you can have two lines in 3D that are still parallel. So they're never going to intersect. Now, for 3D, it is possible to have lines that are not parallel, but don't intersect. In 2D, we would say, oh, if two lines aren't parallel, then they have to intersect at some point. That's not true in 3D. I can have two lines that are not parallel and don't intersect. Does anyone remember the word, what we refer to those lines as? Old geometry class. Those lines are skew lines. So it's only possible in 3D that you have two lines that aren't parallel and don't intersect. So we want to know if these two lines are parallel or the same line. Well, if they're parallel or the same line, one property in particular has to be true, which is what? Whether it was the same line or two different lines that are parallel, what needs to be true for both of these lines?
Cross through the same point and then have the same direction vector.
So they'll cross through the same point if it's the same line, but I agree that they need the same direction vector. Because if they're two different lines, then they're definitely pointing in the same direction. So here we have a line in parametric form. Here we have a line in vector component form. I'm responsible for each of these to pull out the direction vector. So by inspection, we need to be comfortable enough looking at these equations that we recognize that the direction vector is 4, -5, 6. In this vector component form, oh, that looks like this form up here, where we had some point plus t times my direction vector. Well, that means that this vector here is the direction vector. And at this point, I would go, well, those two direction vectors are different. So they're not parallel. But we need to be super careful. It could just be simply scalar multiples of one another. So however you want to do this, totally fine. I think I showed you the technique of make the first component a 1. So I'm going to divide everything in this top vector by 4. And then this is being multiplied by 4. Here, divide everything by -2. First thing, let me know, did I read the question? Let's make this question more interesting. Change the original problem to a positive 5/2 here. The reason I'm doing this is here the direction vectors would be different, so they're neither parallel nor the same line, but that's not interesting. If we change it here, now I have the same direction vector, so they're definitely parallel. So now I think the question of, well, they're two lines that don't intersect, or are they just the same line written twice? And you might go, well, they're different because they've got different points. But any point and tracing out the same direction vector will generate the same line. So two lines can be the same but look different. So here's what I'm thinking we can do. I've got two lines, both have a direction vector, both have a point. I'm going to call this L1 and this L2. Tell me a point on L1, any point that's on the first line. Thinking of our parametric form, we said, oh, well, if we kind of separated this, it would be a point plus something times the direction vector. That means this 1, 2, 3 is a point on the line. And now for L2, give me a point on the line.
3, 9.
Yeah.
This is a point on the line. Now, I want to be super clear that you could have picked any point here. And a way to generate any point on the line is you can just pick any t value. You could have let t be 0, and you get 1, 2, 3. If you let t be 1, then you would have the point 5, -3, 9. Also points on the line. And so on. You could have picked anything. So now here's what I'm thinking. I've sketched two lines up here. I'm kind of pretending for a second that these are going to be two different lines possibly. I'm going to find the direction vector from this point to this point here. And here's just my thought process. I'll put this in a different color so it stands out. Here's my thought process. I'm going to find the direction vector between these 2 points. If I stumble on this being my direction vector, then it means that the point was on the line, and therefore it's the same line written twice. If I find the direction vector kind of like the sketch indicates, and you get something that's not your direction vector, then these are just two totally separate lines, but they still run in the same direction. How do we rock? All right, we'll try again. So I've got two lines, and on L1, I picked a point. On L2, I picked a point. I already know that they have the same direction vector. So I know they're running in the same direction. My only question right now is it the same line, or are they two independent lines? So my way to test that is to pick a point on L1, to pick a point on L2, and find the direction vector between these 2 points. If you get a direction vector different, then they're two different lines. However, if the direction vector ends up being the same, oh, well then both points live on the same line. So I know I have one singular line. So now let's go ahead and try to find this direction vector in blue. 5 minus 1 is 4. -3 minus 2 is -5. 9 minus 3 is 6. divide everything by 4.
Oh, look at it.
So now that I get the same direction vector, help my
Same
sketch
line.
stand out more. That means that that point 1, comma 2, comma 3 lived on the same line. So L1 and L2 are the same.
Okay.
Is it the same one or the same vector?
Same little line. Alright, so I've got some practice problems. Do we want to try these on our own on the whiteboard, or do we want to do them together? I am very confident that you guys can do all of these problems if you work together. All right, go ahead and stand up, grab a marker, grab a checkerboard.
Yeah, because I didn't take any notes. You were moving around today. A lot, so I can't remember the camera.
I have it.
All right, we're gonna record everybody today doing their problems. See if we're gonna get them right.
We're trying to find them that they were identical. My first thought was to, like in the parametric, just plug in the points and see the teeth are the same.
You could. It's a way to do it.
That seems like it'll be longer though.
I was gonna say, it turns out for a lot of these questions, there are many different ways of approaching it. That is definitely a way. Set the x is equal, see if there's the same t-value that makes them.
Not the same, so it'll be can't be different. Okay. Wait,
the point 3, -6, -7. Because you want the line that passes through this point. So that is
Okay.
how is he, where is this coming from? As is, 3, -2, 6. Okay, I see, you're pulling the point from this line. Got it. Okay, so you're just, if you wanna do that, that's fine, put equals plus t. So now you're just showing yourself, this is the direction vector, this is vector, now you wanna generate a new line. This slope, this point.
Okay.
Where did they go to the play?
It's point plus, and then
I kinda got into it, this standpoint. A, B, and C was the individual. Yeah. Right.
But,
His plan was that A is supposed to be with CZ is D.
So for number one, it looks like you're finding the equation to explain.
I know, yeah, that was getting mixed up.
You want the equation to
Did that's good. I don't, what's that equation? Cause I was trying to take a picture real quick and. That's what
Yeah.
Sorry.
You want the
Just saying
point
something.
plus t times the direction vector, if you just wanna think about it as a
Okay.
I would really just go and look at the last
Yeah.
things there and just
Direction.
call them up in order, honestly.
Hey, everybody, we're gonna have a signature card. I had it.
But honestly, you don't have to board by the end of the month, so like no matter
Well, I
what.
have my board.
I know, but like,
I'm like,
yeah,
So
so
why
you're
you
gonna
schedule?
get, you're gonna get ready by then and you're gonna do it, fine, but like, if it comes to the worst,
yeah, I'm not.
you tried and you were super early.
Don't stress.
I can't believe it. No. No, get this.
Yes.
That just equals T minus 6.
First we're gonna.
Looking at the perpendicular
Side.
one, right? A, B, C.
I don't know, some different thing. I know I'm doing. No, cause I said, I'm sure they, right, aren't you supposed to get?
What I did is I just used.
I'm silly, I'm silly.
Zero.
Oh.
They're related to this one. So it's like not the
Oh,
A, this, I think it was this.
That's just what I did.
Yeah, like, it's not working. A, X, B, Y. C, D,
Because we wanna make
equals
T
D.
equal.
I think,
Oh, add
but A, B, and C is the normal.
that'd be there.
Okay,
So,
yeah.
that's like our, the negative
Okay,
factor.
and then, okay, then just point.
That's perpendicular to the plane. We want our line is perpendicular, so this is my, this is slope. This is one.
have point
Okay.
3, -6, -7, and a slope of 2, 1,
Okay, great.
0. So then I'm looking at -3, -6, geometric form is equal to
Oh.
No, it did ask
That's
for
a really
parametric
funky one with the P equals, and we have like this, X something over something, you know? It's like where you take this and you know, like instead of like equal this, it's always
If
like
we-
P.
Well, if you write both on the exam,
Yeah,
you
you're
might be
right.
showing me you don't know what parametric means, so you just write all of them.
Okay, I'll remove that.
Alright, we feel confident with 2.
Okay, so what was this one?
The bottom one they wrote?
Yeah.
Symmetric form.
Symmetric.
And then just read there, yes.
Symmetric. Okay.
It's a 7. Wait, what are you? Okay, that is a 7.
Ooh, somewhere.
Maybe I disagree. That's perpendicular.
So, you're finding the first points, and then you're like, okay, cool, great, I'll start the first points. And then from right here,
Well,
now this is.
Tell me what you're thinking there, because you might not be that far off.
Okay, so,
Straight here, I remember to cut it out.
yeah.
Change the size.
Because otherwise you weren't using it at all, so it's like, why would they?
So
give us
first,
that one?
write this in that standard form, AX plus BY plus CZ
So
equals
that's,
0.
cause you have
Or
your
equals
point, which
something.
is what you're trying to prove. So it's parallel.
Two.
And then you already know what your slope is.
Zero.
You were doing it just using what it's parallel to, so it was like you did the math without improving.
Yep.
So let's just kind of subtract these over, subtract it, and free over. So it's like -2x plus 1.
I didn't know how to do this. Just say equals
So this is our equation of a plane in standard form. The vector perpendicular to the plane is the normal vector. And what is the normal vector of that plane? Just -2, 5. Negative.
So, okay, so that's, I mean,
points for you?
I'm thinking, we need some X value, some Y value, so Z value, it has to be up to 2, right? That's kind of plain definition. So I'm wondering, this might be making hard, but if we look like this, and we just plug in, well, X of T, given this 2 minus pi. And then you got this is how you find it. Three and now you find a Y.
Oh, yeah. So now, and I can convert it and make it like,
And then,
you know,
yeah,
plus Z over here at the end, make it nice.
this is a 3,
Okay, so now in standard.
1 minus 2.
Which is equal to,
Equals to.
So all we have is T. So we just, we have some values, we just like distribute and then combine things here. You know, like a 2 minus 5, plus 3 minus T plus 3 minus
I just wanted-
2 equals 2. Being like combine these and those to get 2 minus 3. Okay, these just cancel. It's just gonna be 0. Wait, let me see, right? Unless it's 2, 1, 1. What's 2, 1, 1 is the intersection?
I just left these two on the same side, because then that is minus 3. Minus 3.
Yeah. I mean, technically, I think it's just, it's one of the one, because you know, even just if you put the 2, you have minus 3 plus, you have minus 3 plus 3, you just plug in these points there, so they cancel out, you get 2 equals 2. So it's the same thing, if we did it this way, because you get,
Because now you have it, there, so this is the slope.
it's like what, minus 17, you get T.
So your point goes first, plus T
Negative
star.
17 T equals 0. So it's just when T equals 0, it's just a starting point. Well, it is the answer.
That's graphically Desmos will justify it to yourself usually. You should be able to graph the point, graph the line, graph the plane, see that the point is the intersection of the line.
It just. That's just. I think. We have a plane that was X minus 3Y. Plus 3Z equals 2.
Did you get it?
You have the plane.
Okay. So now the line, don't forget we write as a chord. So put like a starting parentheses. And then you're gonna type your x of t, 2 minus 5t, comma.
Yeah.
1 plus 2.
Yeah, so I recall it.
Just to make it, change the t from like negative to t. Now, we are saying that that line intersects that plane at what point?
Thought it was 2, 1, 1.
So now, 1, 1, block the point, 2, 1, 1, 2, comma 1, 1.
Yeah, I think this is the equation of, this is the equation of plane, it's just like, in order to lie on the plane, X, Y, and Z has to work out in this equation. So I just, in this case, we'll just go line, we find points this way, but when we put it in zero, this is actually where it is. When we leave zero, it's just the starting point. Just happen to move that way. If it up to two, it's like 1 or something, just plug it back in. Actually, anyways, that's over. Do number 5.
Well, hold down a minute.
Do we just choose which one is gonna do this? Oh, you have to do final lines and insurance, it's just like, it's like the first thing I did. Okay.
For starting point? Yeah. Then we got, -3, 7, 1.
This one I'm all over without the name. 0, 9, check.
0 for 1. -1.
Slope 5t, just 2, negative
And then we just pick one.
But now, how would I write this? Would that,
That's
because there's no,
where it's like.
Yeah, t, so this would be t equals x over 5, check.
That's like me in math, and then I get to like the
Two.
exam, and I'm like, oh.
There is no t.
right, so it's just y equals 2.
Yep,
Yeah.
so you're gonna write
Direct.
t equals x over 5
Not
equals,
No, that's
because you divide it, you divide by 9,
So it could be -9t plus 3, but I probably
Probably.
you still get
3 minus
1 over
Wait,
negative.
there's 0 parallel.
Right.
And then, so how about this, leave it in this form. So now, this is where you write t equals x over 5.
X times X is Y times Y.
So that right there, so, you mean right, right, yeah. T.
Well, how do you have negative?
Equals, equals,
Oh, I think that's
Right.
it.
Yeah.
also equals z minus 3 over negative 9. Normally we would do it here, but since I don't get that, then you can just put comma, and then y equals 2. So that's your solution.
These are.
Okay.
And it's not. Yeah.
So here, t equals, check, we'll check.
Both of them.
But,
It would be negative.
why do you solve for t then c minus 3 over negative 9?
Oh, should I just not simplify it?
This wouldn't be simplified because you still have a 1 up here. Leave it.
Oh.
So now you say t
No,
equals
81, right?
x over 5 equals z minus 3. It's like a chain of equal signs.
It's like, why don't you know?
But then you triple.
And
And then you put a comma.
One, that, or
That's why
zero
it's
and all. one positive for me.
It has to be t equals and all this.
Even scored in two. Great. I need to find both.
So,
The speed was good. Sheet of paper.
talk me through our thought process for five, what we think.
Well, I just called the direction vectors and then I did the.
Oh, okay.
That's about.
I was gonna say.
It's 80, that's 81. This is 70. Plus 11. 81. 81. So yeah, they're perfect, yeah.
Just means a chord, x comma y comes e.
Oh.
Don't ask me to spell it. Also, you know, I'm always like, hey, we go down, I'm like,
No.
There's more.
oh, great, I can start off. Okay, we thought you said four. Over there. I'll trust you to redo this question.
So if this line is gonna intersect, like,
I'll write in the hard spot.
it means that the
Base
x,
of the plan.
the y, and the z have to satisfy this.
So are you, how many points are you using?
So plug in x,
Okay, alright.
plug in y.
We're making two vectors. Two vectors cross product. Yes. I think we should take the start, because then everything else would just make sense. This just be. Okay.
So if the line is gonna intersect with the plane, then it needs to be true that
That is,
the
I remember my name is Jay, I remember my name is Jay.
So plug this in for x, plug this in for y, plug that in for z.
Minus,
the intersection?
minus J. Minus 2, 6, 5, 3. That's good.
Yeah, I was gonna say.
This is -12 minus 6 -18.
so
plug in
negative
X.
15
So this is
Plug
the
in
point
Y.
one, right? I forget what the point something. Or is
Solve for T.
point vector, solve vector point.
Okay.
How this one was, so there's this standard formula that A x plus B y plus C is equal to D.
But it's not, there's an order triple.
So, but if you're picking 0, 0, 0, these just become, you're just multiplying AX and B, Y, C, C. And in our case, D would be 0, right? Because- So if you like if we start writing this out, we're just gonna plug in 0 every time we're just subtracting 0.
Negative 5 minus 3.
The x is just a variable. So if you're just, if like you pick the point A, there is C minus 0. And like we have like y minus 0, so this goes like x, y, z. So we just, so yeah, I'm just gonna cut straight to the chase. So yeah, plus 20.
Okay, so.
22.
Solve for T.
22.
Divide both sides by negative 17.
Equal.
Okay.
Yeah. And
So you found that the
one normal form that starts with
intersects
0,
the
but since you
plane
can't, we
when
don't have any
T
other
equals
constants, we
0.
can only subtract them.
Well, when T equals 0, what would the coordinate be? Think like parametric
Because we don't
equations
have any
at T equals
other
0.
constants.
That means this would have the coordinate.
No, it's just,
What did you say?
The word.
No? What happens when you
I
put
think
T
I
equals
just
0?
divided by x for
Oh, it's just.
Two on one.
Oh, so then that's.
That's the
Oh,
formula.
okay.
Okay. I'll let,
Now,
you number
to
2.
finish for, you found the time when it happens. But you need to actually do it.
Let's see. Equation of the plane passes through the plane.
That's right.
Yeah.
Okay.
Did you finish it? Well, I agree that it happens when T equals 0. So now what is the coordinate?
Oh, coordinate is 2 on 1.
Is that what it's supposed to be?
So how would I write that? Just,
I was just writing coordinate with 2 and 1.
so now, we.
If you wanna label it, you could label it point of intersection.
Okay. And, but it's a point, so yeah, so it's not.
Ew.
Yeah, yeah.
need two vectors at least from one point, so you can do the cross product finding.
So if you're showing that the direction vectors will be the same, you're showing that the lines are parallel.
Oh, if you write it.
We wanna show the lines are perpendicular.
This is just, yeah, I think so.
I am too. I am too, I'm gonna say different thing. No. So,
Yeah. Quick ones. Why did I do that? Why did I do that?
So two lines intersect. Line going this way, line going this way. What would need to be true for my direction vectors to show that they're perpendicular?
Yeah. Alright, so you can.
The vector operation. That would still be a scalable.
Wait, that is the.
Still be parallel.
As,
The
oh,
dot product.
this numbers.
I don't know why I did that.
I don't know what that means, but this is the same. So I'm gonna go back to parallel.
the cross product will be zero.
Oh,
Two vectors.
okay, wait, this direction vector is the same as
Okay,
L2's direction.
so
The cross product gives you
zero.
a perpendicular vector.
Vector.
Well, these two.
No, that's a,
So
that's,
it's
that's
the
because
same,
you're
it's
vector,
not
it gives you,
perpendicular?
right, alright, okay, so I'm just multiplying, to see if I can do,
Dotting them.
dotting them, so. Okay.
The one we did was.
Dotting, so I go L1 dot
The parallel.
2 equals
Well, this one's asking for perpendicular.
21.
Oh, then you pick a point.
Yeah, that's
91.
that's what I did, I put, so on L2's direction, there's this point, because I just want that to the equation. And on L1, there's this point, which I also got distracted from the equation. And I was like, okay, I guess I'll find the direction vector between these two, because I don't know what else to do. And then it equals this, and these are the same numbers as there.
Yeah,
L2,
no.
L2's direction vector.
Is that right, 21?
And that means,
Negative.
I don't know, it means something significant.
Still finishing up here.
6, 7, 8.
Okay, well, you've proven that the parallel.
Oh, the parallels? They are parallel.
Yeah. I'm trying to think about it in my head too.
Okay,
This one.
No, they are, they're not, they are something. They are.
minus.
So it says demonstrate that they're
I feel like
perpendicular.
it's easier to teach when you're sitting
They
out
are
here, you're not doing the math. When you're doing the math, doing the math,
Because-
why do you think it's so stupid?
The direction vector between A and B
So now we have,
is the same
I
as
have the vertical vector and we have the,
He's like, oh.
So we're told that these lines intersect.
whichever point you want.
That means we have one line that has a direction vector. One line that has another direction vector. How can I show that those
Yeah,
two
the
vectors
A was on the
are
line.
perpendicular to one another? Or orthogonal?
Oh, when
You
you
put
cross into
something
the
right
equal
in
zero.
the,
Something's equal to
Dot product.
The
So
vector
wait, I didn't have to
we
do
use
any of this,
is
I just had
our-
to do dot product?
You just have to do the dot product of the two directions.
Say null vector, is that right?
Oh. But you
So
proved
this
it.
dot
Yeah,
product
if
is
it's A, B, C,
zero.
and there's an A and then there's
I know that these two lines.
I don't think so, it proves that they're connected.
Yeah,
I think it just proves that I
so A
know how to
is,
do.
so this is our normal vector.
I don't know.
That was good.
Something, I'm just gonna dot that. It's just gotta be dotted. I forgot how to do that actually. Okay, so this is irrelevant?
Yeah.
Or
so
this
zero.
irrelevant? Ah. Well.
You said the dot product gives zero if the two vectors equal zero?
Well, actually.
Oh, yeah, I'm sorry. Dot product, let me see. Dot product gives the product of zero if the two vectors are parallel.
How do I do that? Oh,
Two vectors are orthogonal, we're not orthogonal, if the two vectors are, so they're at a 90 of each other and, what is that?
You said orthogonal, that's another word for it.
Yeah, perpendicular.
Oh, no, no.
Two vectors, that out of here.
So it's four. Instead of four, I'm like, what?
Sorry.
Maybe 48, and then you're putting it over.
Okay, now.
And that's under four. You did it. I guess we would say if we had a good, find the equation of the plan, what if we just did that was good? Terraform plan.
Sure, it's just dotting is so easy. I love the dots. Yeah, that's about the best.
All right, let's see. Find the point intersection of two points.
Oh? Is this another one?
These are just more.
Oh, okay. I'm supposed to say, oh?
More practice
What work?
problems for you guys to have, the solutions will be posted to Blackboard to.
Or, like, the actual thing.
6 minutes, okay, speed,
So
speed.
you're gonna hit all the projects. So far we have.
I'm just gonna write it like this. Have one minus,
Parametric equation.
P,
Wednesday we'll have the project.
1 plus 2P, right? That's,
Cool.
okay,
Cool,
right. We have
man.
players.
I was tired, you woke me up, that is so great.
So I'm gonna do like what I did earlier.
Cause I was on fumes.
Yeah, mine is
Three,
T.
3:30.
So.
Yes, that was like a shot of adrenaline.